This is the second tutorial of Classification Using Machine Learning and Introduction to Classifier series. This tutorial discusses some of the widely used training and testing methods for classification models. It is a good idea to design a classification model using different techniques because a single technique cannot be suitable for all data. Afterward, the classification model is required to be evaluated using standard performance metrics. Okay, let's start the tutorial. The first method is using a holdout set. This is the simplest kind of cross-validation. In this, the available data set is divided into two disjoint subsets, namely a training set and a testing set. You can split the dataset in any ratio. The preferred ratios are 60:40 or 80:20. However, you must ensure that both datasets are mutually exclusive. That is, the training set should not be used in testing. Similarly, the test set should not be used for training the model. The test set is also called the holdout set. This method is useful when the data set is large enough. However, one major limitation of this method is that the error found in the test dataset. It highly depends on the samples included in the train and test dataset. Also, if the train or test dataset are not able to represent the actual complete data, then the results from the test sets can be skewed. This method is not effective for comparing multiple models and tuning their hyperparameters. This leads us to another very popular form of the holdout method that splits the dataset into three separate sets, which we will see in the next slide. In the holdout method with validation, the given data is divided into three subsets, namely training set, validation set, and the testing set. A validation set can be used for tuning and estimating the parameters of each classifier. The parameters that provide the best accuracy are selected. However, to fully determine that the selected algorithm is correct, the model is applied to the training dataset, again. This is to ensure after the hyperparameters tuning based on the validation set, the model could show the sign of overfitting. Thus, the accuracy we receive from the validation set is not considered final. And another holdout dataset, that is the test dataset, is used for the evaluation of the final selected model, and the error found here can be considered as the generalization error. The next method is k-fold cross-validation. In this method, the data set is randomly divided into k-disjoint sets of equal size. Each fold has roughly the same class distribution. The classifier is trained with k-1 subsets, and the remaining one is used as a test set. This process is repeated k times. The final estimated accuracy of classification is the average of the accuracies obtained for k iterations. 10-fold and 5-fold cross-validations are commonly used. That can be obtained by 10 and 5 partitions of a dataset, respectively. This method is useful when the available data is not large. Leave one out cross-validation is useful when the dataset is very small. And, you want to use as much of your data for training the model. It can be considered as a special case of k-fold cross-validation with k-folds are equal to n samples. N experiments are performed using n-1 sample for training. And the remaining 1 sample is used for testing. It is rather computationally expensive. But it provides the best error estimate possible for a single data sample. Repeating this process n times generates n times mean square error. Mean square error will vary as test data uses a single observation. This can introduce a lack of consistency. The final estimated accuracy of learning is the average of the n accuracies. In this slide, we discuss some of the important performance metrics for a classification model. True acceptance rate is a ratio of correctly accepted owners' attempts to all the attempts made. Higher true acceptance rate indicates that the system performs better in recognizing a legitimate user. False rejection rate is a ratio of incorrectly rejected attempts of a legitimate user to all the attempts made. It can be calculated as 1 minus true acceptance rate. False acceptance rate is a ratio of incorrectly accepted imposter attempts to all the attempts made. Lower false acceptance rate means the system is robust to imposter attempts. True rejection rate is a ratio of correctly rejected attempts of imposters to all the attempts made. It can be calculated as 1 minus false acceptance rate. Receiver or relative operating characteristic is a visual characterization of the trade-off between false acceptance rate and true acceptance rate. In simple words, it is a plot between true alarms versus false alarm. The curve is generated by plotting the false acceptance rate versus the true acceptance rate for varying thresholds to assess the classifier's performance. With this we conclude this tutorial. Happy learning! Thank you for watching the video. Please subscribe to my channel and like the video.